Alright, so this is for knowledge point 4.4.1.6, applications of natural logarithmic functions. And the problem we're given turns out to be a problem about how fast people walk given how many people are in their city. So it was found by psychologists Bornstein and Bornstein that the average walking speed, s, in feet per second, of a person living in a city of population p in thousands is given by the following. S function of p is 0.37 times the natural log of p plus 0.05. Alright, so the first thing we're asked to do is actually pretty easy. We're just asked to figure out the walking speed of a person in Indianapolis, given the fact that there are 836,924 people in Indianapolis. Alright, so we can do that pretty easily. All we need to do is get our function and then plug in this number of the population. So, S function of whatever the population is 0.37 times the natural log of the population plus 0.05. Alright, now note very carefully that it says the population p in thousands. That's important. So we're not going to actually put in 836,924. We can actually just round this off to 837, because there are about 837,000 people in Indianapolis. Alright, so the function of 837 is 0.37 times the natural log of 837. Let's figure out what the natural log of 837 is. To do that, we're probably going to have to use a calculator. So 837, take the natural log, and we get 6.7298. Let's just call that 6.73. Alright, so we have 0.37 times 6.73. So let's take this and multiply it by 0.37. And we get 2.4901. Alright, so 2.49, we'll just call it that, and then plus 0.05. Add that together and we get 2.54. And that should be the average walking speed of a person in Indianapolis. Alright, the next thing they were asked to do is to figure out with a city. We don't know what the city is, and we don't know how many people are in the city, but we know that the average walking speed of a person in the city is about 2.66 feet per second. So I don't know, maybe you're stranded in a city, you don't know what the city is, but you want to figure out what general population of a city is. So instead of asking somebody, you just watch people's walking speed and see how fast they walk. Maybe that'll give you an idea of how many people are in the city. I don't know. Alright, so in this case their walking speed is 2.66 feet per second. 2.66 is 0.37 times the natural log of the population. Remember, that's in thousands, plus 0.05. Alright, well, we're going to try to solve for the population here. So the first thing we want to do is subtract 0.05 from both sides. We get 2.61 equals 0.37 times the natural log of p. And now we can divide both sides by 0.37. It would probably be a lot faster to use our calculator here, so 2.61 divided by 0.37, and we get 7.05405. Alright, let's just call that 7.054. Alright, so 7.054 equals the natural log of p. Now let's remember what natural log actually means. Natural log means the log base e of p is 7.054. Remember, a logarithm is an exponent, so the exponent to which we can raise e and get a result of p is 7.054. So e to the 7.054 power is p. Let's figure that out with our calculator here. Alright, we've got the number here. If we just take the inverse function, it's on my calculator, I don't know what yours looks like, but it says right here if we press inverse or shift and then press this button, it'll raise e to whatever power we have on the calculator. So that's great. We want to raise e to this power. We'll do that and we get 1157.54. We're going to round that off because we don't want to have 0.54 people walking around, so we'll just say 1158. And that's roughly the population of this city. Whoops, no, that's not right. Okay, it's 1157.5 was 0.54, actually, was roughly what we had. And since it says right here in this problem that the population is in thousands, so P is not the final answer we're looking for. It's P,000. All right, so it's 1157.54 times 1,000. All right, so we just do 1157.54, move the decimal over 3 places, and that should be our answer. So 1,157,540 is about the population we're looking for.